Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the idea of radical, and we're going to start off with the definition of square of a number. So let's say you have a number which is a, and if you talk about square of a number, basically it is mathematically defined as a and you square it. So it is the second power of that number. Okay, square of a number, say a, is just a, then you have this superscript 2 on the top part here. So basically it's just the second power of that number. So for example, if you say square of 4, it means you're going to take this value 4 and you square it. So you got 4 to the power of 2 because this is the second power, and basically it means 4 times 4, which is just going to be equal to 16. So that is the first term, square of a number. Next, if you move on to the next term, what is square root of a number? So square root of a number, say b over here, it can be mathematically thought of as what's the number that when you square it, you get b. So you're talking about finding a number that can be squared to get b. So in other words, it is something like this. Mathematically, it will be, this is square root of a number. Sorry, this is b. B is a number. And then we are going to find what is x, such that when you square it, you get the value of b. So square root of a number, you're looking to find this value here, which is x. Basically, that's what it means, yeah? So for example, square root of 16. So square root of 16 is going to be 4 and negative 4. 4 and negative 4. So 4 and negative 4 are the values of x. Because when you square 4, you will get 16. And if you squared negative 4, you will also get 16. So 16 here is b. So we can think about this value of 16 here is b. According to this, what I have wrote over here, I have written over here. So square roots of 16 is this value here x, where x is 4 and negative 4, because these are the values that when you square it, you will get b. Okay, so you can see over here as what I have written so far. 4 to the power of 2 is 4 times 4, which is 16, and also negative 4 to the power of 2. So negative 4 to the power of 2 is negative 4 times negative 4. You will also get 16. So basically, square root of a number is a number here that whenever you square it, you will get the value of b. Now, you can see that every positive number, so positive number, for example, 16 here, the value of square root can be positive. For example, this is the value of positive square root, and this is the value of negative square root. So every positive number has a positive square root and a negative square root. Alright, so the next idea is most of the times we are always interested on the positive square root of a number. We are interested on just the positive square root of a number, and because of that, we indicate our interest by using this radical sign. Okay, and positive square root of a number is also known as principal square root of a number. So we're just concerned with the positive square root of a number. So for example, the square root of 16 is written as this one. So this is the square root of 16, and the answer to this is just going to be 4. Because we are just dealing with the value of positive square root. So whenever you see this radical sign, basically it means that you only need to find the value of x here that is just positive. So square root of 16 is 4, or square root of 9 is 3. So you don't need to consider the negative square root. We're just dealing with only positive square root. Now it is also possible to write the square root of 16, such as this one, in terms of fractional exponent. So in terms of fractional exponent, this is equal to 16 1 over 2. So this is what it means by fractional exponent. And you will see more examples of this in the next page. Yeah? Okay, so in general, again, let's talk about the principal nth root of a real number, which means you're just dealing with positive value, positive nth root, and that's why we are using the radical sign. Okay, radical sign, which is this one. Therefore, if you are interested in whatever nth root, it can be 2, it can be 3, 4, 2, 3, 4, and so on, then the general way of writing it is going to be in this form. Okay, so for example, this one can be 3, 4, 5, and can be 3, 4, 5. This is what we call radicand. B is radicand. This is what we call index. And this is what you can mathematically write our interest to find the principal nth root of a real number. So once you got this, it indicates that b is equal to a to the power of n. Now, how did we get this value? Now remember this notation here. Okay, so I'm going to show how from this we get this. So what we have is this radicand, and then we have the principal nth root is equal to a. Notice that this thing here can be written in terms of fractional exponent. This is equal to b 1 over n is equal to a. And if you want to get rid of this 1 over n exponent, we have to multiply the whole thing here with exponent n outside. And if you introduce something on the left side of the equation, you also need to do the same thing on this side. And you can see that based on the law of exponent, if you simplify this expression, you're just going to multiply these two exponents together. So if you multiply these two exponents together, you will be able to get rid of this, and then you will be left with just b. B is equal to a to the power of n. So this is how we get this part over here. Yeah. So as an example, let us consider this one. Okay, this one over here. So we have I'm going to write down this term with fractional exponent in terms of fractional exponent. So it will be 8 1 over 3 is equal to 2. And then I'm just going to get rid of this exponent here, this fractional exponent. Therefore, I need to multiply that with exponent 3 outside. And if you introduce something on the left-hand side, you have to do the same thing on the right-hand side so that you get the equation balance. Yeah? And from here, you can see that if you simplify this expression, the two exponents here should be multiplied together. And if they do, we can see that this one will be cancelled out. So you get 8 is equal to 2 to the power of 3, which is correct. Yeah, 8 is equal to the 2 to the power of 3. So in this case, this is the principal third root of a real number. So 2 here is the value that we are looking for. Okay, so now note that for any numbers such as a and b, we have a is greater than or equal to 0, and b is also greater than or equal to 0. So we're going to use all these rules that you can apply in order to solve radical expression. And I'm just going to show to you how from this left hand side we get this value over here. And it is very simple, and we're just going to use the idea of laws of exponent, which you have already seen in the previous video. So I'm going to start off with this part here. Let me just erase some of the slides. Okay, so let's move on to this first. Okay, here we have square root of a times square root of b. And here what we can do is, if you want, you can write it in terms of fractional expression. It will be a 1 over 2 times b 1 over 2. And based on the idea of exponent, if you have the laws of exponent, if you have the same value of exponent here, you can combine a and b together. So you have a and b, put it together, 1 over 2 is going to be outside here. And this is simply AB, and then we're going to use this sign. So there you go, you got this part. Okay, right, next let's move on to this one. Okay, so again with the similar idea, we have square root of a times square root of a. Fractional exponent is going to look like this. Okay, and then we can see that we have the same value over here, so we can consider them together. So we will have a 1 over 2 plus 1 over 2. So this is the law of exponent. So when you have the same base, you can combine it. I can do it like this, a, so the exponent will be added up. Alright, so then it becomes 1 over 2 plus 1 over 2 is a to the power of 1, obviously, and this is just equal to a. So by doing this, if you multiply the same term over here with this radical sign, you'll be able to get rid of the sign over here, and you just be left with a number, simple number, which is just a. Okay, now how about the third one? So for the third one here, we normally use this idea if you want to rationalize the radical term, which means you want to get rid of this term. So you want to get rid of it, you don't want to see this term anymore. So you can see that the result here doesn't have the radical term anyway. Okay, so this is the idea that we can use, and you will see this in examples later on, how to get rid of the radical term. Okay, so let me just show you what's going on this part. So we have square root of a plus square root of b, and we're going to multiply that with something that has an opposite sign to this term. So the opposite sign is going to be minus square root of b. So we're going to start with that. And in any sort of multiplication, we know that this is going to be multiplied with this is also going to be multiplied with that, this is going to be multiplied with this, and this is going to be multiplied with that. So it is going to be a long expression, but I'm sure it is not that daunting to do it. So we're going to do it one by one. So first, this is going to be equal to square root of a times square root of a minus square root of a times square root of b plus square root of b times square root of a minus square root of b times square root of b. Now over here, according to this law, we know immediately it's going to be equal to a minus, you can see that you have the same exponent here, which is a half and a half, and you can combine them together, so it will look like this. Yeah, so you will have square root of ab. The same thing for this one, you have the same exponent, fractional exponent actually, or radical term here. So you can combine this together, ba, it doesn't matter ba or ab, it's just multiplication, which is commutative really, and this one is minus b. So according to this rule over here. Now you can see that for this one, it can be cancelled out because it is the same term with different sign. And finally, the final answer is going to be a minus b, which is given by this one. So that is quite simple, really. Now let's move on to this part over here. These are some examples on how you can use or interchange the fractional exponent and radical, and you can look at these examples and maybe perhaps play around with it so that you get yourself familiarized with the whole thing. And maybe before we end this video, I'm going to show you one or two examples related to using the ideas of the laws that you have seen just now in order to solve the following expressions with radical terms. Yeah. Okay, so it says here explicitly that you are not supposed to use the calculator, so we're just going to try and manipulate this. For example, for question A here, we have 4/25, and we know that according to the law which you have seen just now, this is just equal to square root of 4 over square root of 25, and we know that square root of 4 is 2, square root of 25 is 5. So this is quite straightforward. Now how about the second question, B? So we have 1.44, and 1.44 might not be a familiar number, but 144 is pretty familiar. 144 is just 12 times 12. We know that. So I'm just going to manipulate that by writing 144. So I'm going to write 1.44 in terms of 144 over 100. So you can see that 144 over 100 is the same thing as 1.44. Yeah. And by doing that, I make it so much easier because then what I can do is I can separate the terms here. We have 144, the square root of 144, and the square root of 100. And this is just equal to 12. You know, 12 times 12 is 144. And over here is going to be 10. So 10 times 10 is 100. And you can simplify it further by having 6 over 5. Okay, so that is just two simple examples on how we can solve it without using the calculator. So I think I'm going to stop here right now, and I will see you in the next video with more examples related to radical expressions. Thank you very much for watching.